Welcome guys, my name is DrAvitech, and in this video I will be teaching you how to answer calculus questions for JAMB. Now this very video is for that student who wants to solve every single question on calculus correctly on the day of the exam. So without wasting time, I will be solving about 30 questions in calculus, including differentiation, application of differentiation, integration, then application of integration. And on this side we have the rules of differentiation. So I'm just going to come to this portion at any point that I need. So I'll just come here, then explain, and then we'll go back. So let's get started with the first one. Now of course I'm going to be writing the equations on the board. You could try to solve them before I start. Remember to hit the subscribe button, like this video, and share it across to other students who will be taking JAMB also. So let this be a revision for just calculus, only calculus. So the first one says if y is equal 3x squared plus 4x take away 2, you have to find dy dx. All right, so what do we do in this case? Now, if you have a sum or a difference, I didn't write it here because it's not that important. If you have the sum or a difference, this is a sum of two things, and this is a difference. What you basically have to do is to differentiate each of them. So this means that dy dx will become, you have to differentiate 3x squared. Now come to this rule. You see that when there's a number in front, you have x and then a power. To differentiate, you will say a times n, so that number in front times n, so that's an, and then you write your x and you minus 1 from the power. So in this case, this will be 3 times 2, 6. Then you write your s and you say 2 minus 1, 1. So I'm basically following the rule on the board. And then plus, this is 4x. There's an invisible 1 right on top. So this will be 4 times 1, 4. You write your x, then you say 1 minus 1, 0. Because you must always minus 1. Now next, this is minus 2. But this will be 0, right? It's going to be 0. Because it says if you have y equal to k, then dy ds is equal to 0. This is trying to tell us that you are differentiating this thing with respect to s. What this dy ds means is differentiate y with respect to s. The ds part means with respect to x. But this expression does not have x. If it does not have x, then this definitely has to be 0. Because there's no s in the expression. Now this is minus 2. If you differentiate minus 2, you will also get 0 because it does not have x. So that's why that one will go away. So this will become 6x. You know, anything to the power of 1 can just be written as 6x. And then plus s to the power of 0 is 1. 4 times 1 is 4. So this will just be 4. Now another way this answer can be written on the day of the exam is look at 6x and look at 4, 2 is common. So this will be 2 bracket 6s over 2 is 3x plus 4 over 2 is 2. So you see that this is how to answer this very question. Next one, number 2. If y is the square root of x, you have to find dy dx. So this is second problem. We're just doing differentiation. Now, each time you have a equation on something like this, what you're going to do is to try to make sure that the x has a power. So in this case, this will be y equal x. Now, this very square root you see, in indices, it means that the power is a half. That's what it means, that the power is a half. Now, we can differentiate. So we're going to say dy dx equal, we're using this very rule. So when you see the x, you have a power. The power we times the number in front. So in this case, that power in front is 1. There's an invisible 1 right here. So you have to say 1 times half. So this will be half. Then you write your x. And then you say what? You say half minus 1. Because you must always minus 1. So this will be half. Then x. What is half minus 1? Half minus 1 is actually minus half. Yup. Let me see if I can show that. Oh God, I don't want to. Okay, let me show it here. So half minus 1 over 1. LCM is 2. 2 divided by 2 is 1. 1 times 1 is 1. Minus 2 divided by 1 is 2 times 1 is 2. So 1 minus 2 is minus 1. So you could just take the LCM at that very point. Now this will be half times, in indices again, this is minus. To clear out a negative power, we take the inverse of that very thing. So this will be 1 over x to the power of what? Half. Now this will be 1 over 2 times 1 over. Anytime you see the square root guy, it means, anytime you see half, it means square root. So the answer of this will become 1 over 2 root x. But then, there's a very simple way of solving this. It's a shortcut that I always use. So see what I'm going to do. Just see what I'm going to do for the third question. Whenever I have square root function, here's what I will do. So if, for example, oh, I've not even got to that part yet. Anyways, for now, I'm just going to skip. I will show you about the shortcut later on. So if y is equal 1 minus 2x to the power of 3, you have to find dy dx. Now take note, this is not just a revision. These are possible questions you could see in calculus in your exam. These are likely exam questions, well predicted. So this is what we have. We have y is equal 1 take away 2x to the power of 3. In short, find dy dx at x equal to minus 1. Okay, so what do we have to do? Now, y is equal 1 minus 2x to the power of 3. Now, let's come to this very rule here. So, you have y equal u to the power of n. What this is telling us is this u you see here is a function of x. U here actually has x. So in this case, our u is what? 1 minus 2x. And then to the power of what? To the power of what? 3. So, we're going to be using this rule. But then, that's actually stressful for me. So, see what I will do. That's the rule, but here's what I will do. It's a better way. So this is dy dx equal, when you notice something like this, let's differentiate normally. You know there's a 1 here. So 1 times 3 is 3, then bracket 1 minus 2x, close bracket. Then you say 3 minus 1, 2. This is how you normally differentiate, following this very rule number 2. That's how you will normally differentiate. But then, this bracket, because it's a chain, this bracket, you have to also differentiate it. So you say times, differentiate 1. 1 is a constant. It does not have x. We're trying to find dy dx, but there's no x with 1. So that would be 0. No need for us to write that. And this is minus 2x. If we differentiate minus 2, what would we get? We'll get minus 2. Remember that this x here has a power of 1. So minus 2 times 1 is minus 2. Then you write your x. 1 minus 1 is 0. But then, if x is raised to the power of 0, anything to the power of 0 is what? 1. So that means minus 2 times 1 is still minus 2. So you see that the answer will be minus 2. Let's come here. This is 4x. When you differentiate 4x, you will get 4 at the end of the day. So you could know that shortcut so you don't stress yourself in the exam. Now, 3 times minus 2 is minus 6. So this will be minus 6 bracket 1 minus 2x to the power of 2. So this is now the answer. This thing you see here is now the answer when you differentiate. But now it says, find dy dx at s equal to minus 1. So at s equal to minus 1, anywhere you see x here, you put minus 1. So dy dx is minus 6 bracket 1 minus 2. S is now minus 1. So anywhere you see x here, you put minus 1. So this is minus 6 bracket 1 plus 2, because minus times minus is plus. Now this is minus 6 bracket 3 squared. So this is minus 6 times 9. So this will be minus 54. So that will become the answer to the equation. So it's minus 54. If they say differentiate only, this will be your answer. But if they say find it at s equal to a particular point, you see that number, put it inside the derivative. Anywhere you see x, put that very number. So let's move on to the next one, question number 4. Question number 4. All right. So we have this. Well, to find the derivative, find the derivative of y equal x to the power of 7 minus 2x to the power of 5 over x squared. All right, so this is what we have. Now, in this case, you see that something is being divided by something. Something is being divided by what? By something. But the rule looks like this very number 5. Of course, it is the number 5. So we have u over v. Something is being divided by something. We call this the quotient rule. But that's very stressful, especially if what is dividing is a single term. This thing you see here is a single term in mathematics. And it's going to be strenuous, it's going to be stressful if you use this very rule. So what JAMB expects you to do is, there's a way to simplify this. So y will become x to the 7 minus 2x to the 5. Now, they are both divided by x squared, which is just a single term. So you can now share it. This x to the power of 7 divided by x squared, then this one divided by x squared. You share it. So you simplify the expression. Now this will then become y equal x. Remember that in indices, if you are dividing, you have to subtract the powers, right? So what is 7 minus 2? That will be e, that will be 5. So 7 minus 2 is what? 5. Then minus 2, this is s to the power of 5 and s to the power of 2. If you are dividing, you subtract. So this will be x to the power of what? 3, because 5 minus 2 is what? 3. As you can see, the division has disappeared. Now, the expression looks nice, so we can differentiate. So we could say dy dx is equal, differentiate s to the power of 5 very fast. What would it be? This would be 5x to the power of 4. So you see, it's actually easy, just following the rule in your head. So there's a 1 right here. 1 times 5 is 5. Then you write your x and you say 5 minus 1, 4. So you can just practice and you see that the rule is actually very simple. Then minus 2 times 3 is 6. Then you write your x. 3 minus 1 is 2. So that will be the answer when you differentiate. That is the answer. Now take note, JAMB can decide to factorize. So it will not look as if the option is no. It's still going to be the same. So let's just factorize so that either you see this one or you see the next one I'm about to write. So this is s squared bracket. Why did I bring x squared? Because x squared is common between these two things. So we factorize. 5s to the power of 4 divided by x squared is 5x squared. And then minus 6s squared divided by x squared is 6. So this is another way the answer can be written. So just be aware. That's another way the answer can be written. So that's number 4. Number 5. Question number 5. I think I wrote this somewhere. Oh, so if y is equal x squared minus 1 over x, comma, find dy dx. One thing about some questions in calculus is they will give you a function, but it's not straightforward. For example, this one was straightforward. This guy is not straightforward because we have to apply the laws of indices before we now differentiate it. This one is straightforward. Just apply the rule of differentiation. This one is not straightforward. We have to simplify first using the laws of, indices. But first we use, Hold on, let me remember what this rule is. Distributive. Yeah, we have to distribute this x squared to this one and the s squared to this one. So you see that there are some questions that you need to just calm down and simplify first. For example, this one is an example. So y is equal s squared minus 1 over x. Everything already looks nice because the x squared is okay. That one, if you differentiate them, is so easy. But the 1 over x is not really nice because I want to use this very rule. In fact, the goal most times is to make sure that you have this very rule so that life will be easy for you. It's to make sure you have this very rule. So I don't like the 1 over x. So this is y equal x squared minus, there should be another way to write this. And what's that other way? X to the power of minus 1. Laws of indices. If you have 1 over something, you see the power here is 1. So if I want to remove this 1 over, this power of 1 here would carry minus 1. Assuming this place was a 2, for example, if here was a 2, that means when I take out the 1 over, this will become s to the power of minus 2. It's called a negative index law. But let's go back now, 1 day here before. So I put the 1 back, minus 1. Now we can differentiate. So dy dx will then become, this is x squared. So let's differentiate x squared, we'll get 2x. You see there's a way you can do that very fast. So there's a 1, this is our x, right? So you say 3 times 2. Here, there's an invisible 1 here, so this will be 1 times 2. So that's 2. Then you write your x, and then you say 2 minus 1 is 1. And then minus. Now there's an invisible 1 here. So we have to say 1 times minus 1, that's minus 1. Then you write your x, and you say minus 1 has been here before, and then you minus 1. Why are we minusing 1 again? Because the rule has a minus 1. Now this will become 2x to the power of 1 is still the same thing as 2x. But minus times minus here will give us plus. Then you write your x, minus 1 is minus 2. So this will become 2x plus. Remember that this is a negative power. We could take it back to what it was before. So this will become 1 over. The moment we put 1 over, this minus goes away. So this is x squared. Now this is the answer to the equation. It's a very nice one. This is the answer to the equation when you're asked to differentiate. So that is it. Okay. Let me see if I have another nice one before I move to something else. All right. Okay. So I said I will talk about something like this. So let's see. That's number 2. Number 3. If y is equal to the square root of, let's say, 4x minus 3, and we're to find dy dx. Here's how I'll do it very fast. Whenever I have this square root function, to find dy dx, so this is dy dx, to find dy dx, I would always say 1 over 2 with this whole function. So with the square root of 4x minus 3, then times differentiate the 4x minus 3. Differentiate 4x, we get 4. Of course, the minus 3 is a constant, so only the 4 will stay. Now 2 here is 1. 2 into 4 is 2. So the answer will then become 1 times 2, which is 2, divided by the square root of 4x minus 3. This will be the answer. So you see, I didn't have to go all through the steps of it's stressful. So I'll just use this. So whenever you see the square root function, square root of x, always know that it's going to become 1 over 2 with that very square root. And then times, in this case, if you differentiate x, you will get 1. That's why the answer stayed the same, because anything times 1 is that same thing. But in this case, when you differentiate your 4x, you will get 4. So the answer will not really stay the same. Now, someone might be asking, what if there's a number here? What if there's a 2 here? Of course, if there's a 2 here, what you have to first say is 2 times. So this answer will then be doubled. The number here does not change anything. So if there's a 2 here, this will become 2 times. You first start with a 2 times. It's a constant multiple. So if there's a 2 here, it means this answer will multiply by 2. If there's a 3, so we multiply by 3, and just like that. This is not number 3, by the way. This is number 6. All right, let's move to the next one. Number 7. So question 7 says, if y is equal 3 into 2s squared minus 1 squared, or to find dy dx. Okay, now this is also chain rule. Why is it chain? This number 3. But remember, I don't like using it, so let me not even talk about it. So y is equal 3 into 2s squared minus 1 squared. So dy dx, remember I said the first thing you do is to what? Differentiate this the normal way you do. 3 times 2 is 6. Then you write 2s squared minus 1. Then you say 2 minus 1 is 1. Then times, differentiate this bracket. You see this bracket here? Differentiate this. 2s squared, when you differentiate, you will get 4x. Then minus 1 is 0 when you differentiate it. Now what is 6 times 4x? Sometimes it's hard to differentiate between my times and my x, but this times, so let me use a dot to represent it. Hope you know that dot means times in maths. Okay, so 6 times 4x will give 24x, and then you put this guy, 2s squared minus 1. That would be the answer. That would be the answer. Let's move on to the next one. This is number 7. Number 8. Number 8. All right. Ah, shit. Okay. So if y is equal cos of minus 4x, you have to find dy dx. All right. So for this one, y is equal cos of minus 4x. Now what's dy dx? We could do this straight ahead. So follow through what I'm going to do. If you are differentiating a trig function, what you have to do is differentiate the angle first. So differentiate this minus 4x. What would you get? Differentiate minus 4x, you should get minus 4. Just follow the first, this very number 2. Follow the rule number 2. This plus 4x, right? So if it's minus 4, so when you differentiate, you will get minus 4. So you have to first of all say minus 4. And then times, let me use dots to represent times. Times, differentiate cos. Come here. They said if y is equal cos x, it means that dy dx is minus sine x. So if you are differentiating cos, you will get minus sine. So this will be minus sine. Then you put this angle back, minus 4x. That's what you have to do. So minus times minus will give us plus. So this will just be 4 sine minus 4x. That's what the answer would be. This is what the answer would be. All right. The next one, that's number 8. Number 9. Question number 9. I don't know why I still puts. Okay. So if y is equal 5 sine 3x, find dy dx. Okay. Now in this case, it's still the same thing. Y is equal 5 sine 3x. So dy dx would become, to start with, there's a 5 here. So I first have to write 5. Then times, this is 3s, the angle. Differentiate this 3s, what will you get to? We get 3. Now this is sine. When you differentiate sine, you will get cos. So this will be cos. Then you put the angle back, 3x. So the answer for this will become 15 cos 3x. So you see, it's actually something simple. It's not hard. It's something very simple. Next one is number 10. Number 10. So if y is equal 3 cos x over 3, you have to find dy dx. All right, so this is what we have. First of all, y is equal 3 cos. Do you know that this is actually 1 over 3x? Do you know that this is actually 1 over 3? 1 over 3x. All right, so what will be dy dx? First of all, let us write our 3 down. This very 3 in front, let's write it. Then times, differentiate the angle. This is 1 over 3x. If you differentiate 1 over 3x, you will get 1 over 3. That is what you will get. So just follow the rule. This is x. When you differentiate this 4x, we got 4. I don't know why I like coming to this example. When you differentiate 4x, you get 4. So if the number in front was not 4 but 1 over 3, it means the answer will be 1 over 3. And then times, differentiate cos. When you differentiate cos, you will get minus sine. So this will be minus sine. Then you put the angle back, x over 3. Now 3 we cancel out 3. So what's remaining will become minus sine x over 3. That will be the answer to the, it's as simple as that. That will be the answer to the equation. That's number 10. Number 11. Number 11, we're close to the end of all of this. If y is equal x sine x, find dy dx. All right, now for a question like this, you can't escape it. You must use this very rule, uv. Now, why did I say you must use that very rule? This is x. S is times sine x. There's no way for you to simplify it. These are two things. They have x. Both of them, they both have x. And you cannot simplify it further. So it means this x will stand as the u. Then the sine s will stand as the v. Then you apply that rule. But of course, I know we really get that time inside the exam. So here's what I will do. Y is equal x sine x. To find dy dx, what I will do is, listen, I will write my s down. Write x, then times, differentiate sine x. When you differentiate sine x, you get cos x. So this is cos x. Then plus, remember, say the first time we picked our s, the first time we picked x. Next time we pick is sine x. So I will pick sine x, then times. I will now differentiate x. So when you differentiate x, what will you get? You will get 1. Take note, you pick one, differentiate the other. Pick one, differentiate the other. So this is x. When you differentiate s, you just get 1. It's as simple as that. You just get 1 by following this very principle. Remember that s is raised to the power of 1. So if you differentiate this, the s will go because 1 minus 1 is 0. All right. So the answer to this will become s times cos s is s cos x, and then plus sin s times 1. Take note, even if the thing that is here is x, don't go and times it with this very s. Whatever is here would actually be in front. So this will be 1 sin x, or you can just say sin x. Don't go and say that, because if this were to be s squared, for example, if this were to be x squared, for example, it means when you differentiate, you will get 2x. Take note, that very 2x will be in front. Don't go and use 2s and not times this very s. This s so is untouchable. You cannot touch it. So it's an angle. You cannot go and touch it. So be very, very careful. So this will be the answer. Take note, in the exam, they can write the sin s first. So they write sin s first before writing s cos x. And it's still the same thing. It's not something hard. Okay, let me see if I can if I can solve the question 12 with this little space left. So question 12. If y is equal sine squared 3x, find the y dx. All right. Now for this one, you have to be a little bit careful, because the first thing you need to realize is when you square a trig function, the square is always with the function. Let me explain it like this. If you have sine x all squared, for example, this will be written as sine squared x. So be very careful. So it means this thing you see here is actually going to become sine 3x all squared. That's what it's going to be. Sine 3x all squared. That is what it's going to be. And then we can now apply our rule here. But be very careful. This rule, there's a function inside the function. So be very, very careful. So first of all, let's differentiate this the normal way. Remember I told you that this, look, this equation, and this equation, they all operate the same way. They all operate the same way. So there's a 1 in front of this. So 1 times 2, that will be 2. Then you say sine 3x. And then 2 minus 1 is what? 1. You differentiate normally. This is how you differentiate normally. And then times, you see this bracket too, it has x. So let's differentiate it. So differentiate sine 3s. If you want to differentiate sine 3s, what do? You start from the angle. Differentiate this 3s, what will you get? You will get 3, first of all. Then next, differentiate sine. This sine. When you differentiate sine, you will get cos. So this will be cos. Then you put the angle back, 3x. Now with this, what they're going to be having, remember that n to the power of 1 is that same thing. So this will be 2 sine 3x multiplied by 3 cos 3x. So what we're going to be having will become 2 times 3 is 6. Then you say sine 3s cos 3x. This is what you're going to get. JAMB asked a question like this in 2022, 2023. That was when they asked a question like this. Around that time, that was when they asked a question like this. Okay. So the next one, question 13. I think I'm going to be solving more than I actually calculated. I wanted to solve only 30 questions. But it seems the more I stand here, the more I think of possible problems that JAMB could set. So if y is equal sine s cubed, find the y dx. Now see, the reason I thought of this is some students might go and confuse this to this. They're not the same. You see this guy you see here, it's only the s that has the power of 3. See, sine s cubed is not the same thing as sine s all to the power of 3. It's not the same. This one also is different. So this is, let me write the way this thing is supposed to be for you. This is y equals sine s cubed. That's what it basically means. So be very careful. Now let's differentiate this. So dy dx will become this guy. First of all, s cubed has to be differentiated. When you differentiate s cubed, you should get 3x squared following the second rule. This very rule you see here. You should get 3x squared. Now this is sine. When you differentiate sine, you will get cosine, cos. Then you put the angle back, s cubed. Ladies and gentlemen, this is your answer. this will be the answer to the question. Okay. So the last one on something like this, kind of like the last one. Find the derivative. Find the derivative of y equals sine 2s cubed plus 3x minus 4. My God. Okay. This is very simple also. It looks just like this one. So, dy dx will become, first differentiate this angle here. When you differentiate 2s cubed, you will get 6s squared, following the rule. When you differentiate 3s, you will get plus 3. So this will be together. And then when you differentiate sine, what will you get? You will get cosine. Then you put this whole angle back. 2s cubed plus 3x minus 4. There's not enough space for that. So this is what we are going to be getting as our answer. Or you could write it like this. When you take a look at this, 3 is common. So this will be 3 brackets. 6s squared divided by 3 is 2s squared. And then plus 3 over 3 is 1. Then cos 2s cubed plus 3x minus 4. So this is just another way to write it. That's so tiny. So I have to wipe the board. All right. So let me take care of the board and we then continue. Okay. So this section will be on application of differentiation. That's what this portion is going to be on. Okay. Oh gosh. What number was that? I think that was number 14. Gosh, I've lost count of the number. But I think that's number 14, the last one. So this will be number 15. So number 15 says, find the gradient. Find the gradient. Find the gradient of the function. Y equals 3s cubed minus 4s squared plus 5x minus 3 at minus 2, 1. Okay, so this is the equation we have. One of the application of gradients is to find what's it called? Is to find gradients. That's one of the application. So first of all, y is equal to 3s cubed minus 4s squared plus 5x minus 3. Now let's differentiate. So dy dx will give 3 times 3 is 9. Then you write your x. 3 minus 1 is 2. Then minus 4 times 2 is 8. Then you write your s and you say 2 minus 1, 1. Plus, there's an invisible 1 here. So 5 times 1 is 5. You write your x. And then 1 minus 1 is 0. This is a constant, so just throw it out. This will be 9s squared minus 8x plus 5. This very thing that we found is the gradient. This is the gradient. So, I could call this gradient. So that's our gradient. Now, remember that if you're given a coordinate, the first one is always x, second one is y. The first one is always x, second one is y. So, anyway I see x here, because it's only x that we have. So anyway I see x, I'm going to put minus 2. So this will be 9 brackets minus 2 squared minus 8 brackets minus 2 plus 5. This will be 9 into minus 2 squared is 4. Because that's minus 2 times minus 2. Minus times minus here is plus. 8 times 2 is 16. And then plus 5. 9 times 4 is 36. And then 16 plus 5 is 21. So this will be giving us 57. So that will be the gradient. The gradient is 57. Okay. So that was a nice one. Okay, the next one, number 16. Number 16. All right. What is the rate of change? What is the rate of change of the volume V of a hemisphere, with respect to its radius. So its radius arrow when arrow equal to 2. All right, so the first thing we should do first is, what is the volume of a hemisphere? What's the volume of a hemisphere? The volume of a hemisphere is 2/3 pi arrow cubed. That's the formula for volume of a hemisphere. And then they're telling us to find the rate of change of the volume with respect to radius. So that's dv the arrow. Listen, anytime you see two things dividing, that's actually rate. Anytime you see two things divided, that's actually what? That's actually rate. So in this case, we're looking for the rate the volume is changing, so that's dv, with respect to the radius, so that's the arrow. So first, let us differentiate this thing with respect to arrow. So this will be 2/3, then times, it is with respect to arrow. So what power does arrow have here? Arrow has the power of 3, so we say times 3. Then we put our pi. Hold on, let me use a dot. Yeah, let me use a dot for this. Let me use a dot 3. And then put your pi. Pi is a constant here. Then this is arrow. Then you say 3 minus 1 is what? 2. Now 3 can cancel out 3 here. So this will give you 2 pi arrow squared. So that would be the change in volume with respect to radius. But then it says that arrow is equal to what? 2. So this will be 2 pi times arrow is 2. So that's 2 squared. Now 2 squared is 4. 4 times 2 is 8. So this will be 8 pi. So that would be the change. That would be the change. Okay. That would be the change. Next one. The next one is a funny one. 15, 16, 17. The radius arrow of a circular disc is increasing at a rate of 0.5 centimeter per second. Full stop. At what rate is the area increasing? Is the area of the disc increasing when its radius is 6 cm? All right. So the thing is this: every single thing that we've been given, I'll write them in terms of rate. So the radius arrow is increasing at this rate. As you can see, this is radius and this second means time. So this will become the arrow dt because it's with respect to time. So that's 0.5 centimeter per second. As a math student, the units might not really matter in this case. Since you are just writing JAMB, it might not really matter. And the question is, at what rate is the area increasing? So we're asked to find the A dt. That's basically what they're trying to say we should find. At what rate is the area increasing? So the A dt. If the radius is 6 cm, so radius is 6 cm. So first of all, let's do something. We're asked to find the A dt, so let me write the A dt. So the A dt is equal, we're given the arrow dt, so this will be the arrow dt. Now if you notice, we already have our dt, Abi, but we don't have our dA. There's no dA. So let me say times dA. Let me say times dA. Now if I say dA, this is now our dA dt, which is what is here. But there's a the arrow at the top. We don't need it. So what do? We divide by the arrow. And this then makes sense because when the arrow cancels out the arrow, we then have only the a over the t. Now let's come back to this very expression. Let's come back to this very expression. If you look here, you notice that this is du, right? When they cancel out, what's left is dy dx. So this is like chain rule. It is like chain rule. So that's how to solve this one. Okay. Now, next thing we'll do is, we have this, but we don't have this. We're looking for this, remember. We have this, but we don't know what this expression will be. First of all, let's find the expression. Let me look for it right here. This is the a, the arrow. So, first of all, what is a? What's the area? The area of a circle is pi arrow squared. So, what's the a, the arrow? The a, the arrow will be the perimeter. That might not make sense, but let's find it. So, the a, the arrow. Let's differentiate this with respect to arrow. There's an invisible one here. 1 times 2 is 2. Then you put your pi and you say arrow 2 minus 1 is 1. And you know you could decide not to write it. So this is the formula for the what? The perimeter of a circle. So let's put this in. So the a, the arrow, sorry, the t is equal. What's the arrow, the t? The arrow, the t is 0.5. So I'll just leave it at 0.5 times what's the a, the arrow? The a, the arrow is 2 pi arrow. Alright. Now what is 0.5 times 2? 0.5 times 2 is just 1. Because 0.5 is half. Half times 2 will give us 1. So this will just be pi arrow remaining. But then remember they said that the radius is what? 6 centimeter. So this will become pi times 6, which will just be 6 pi. So that will become the answer. If you would need a unit, this will be centimeters squared per second. That will be the answer. So that was a nice one. All right, question 18. Question 18. Let's see. Find the minimum value. Find the minimum value. Find the minimum value of the function. Y equals 3x squared minus 2x plus 5. Okay, so what we're going to do here is, if you're looking for the minimum value, there are different ways to solve this. There's even a way in algebra. You must not use calculus, but let's use it in this case. Y is equal to 3x squared minus 2x plus 5. First of all, let's differentiate. So dy dx will become, differentiate 3x squared, you get 6x. Differentiate minus 2. Minus 2x, so you get minus 2. Differentiate 5 is 0. It's a constant. All right. Now, this thing you see here, if you're looking for the minimum value, it means the lowest point. At that lowest point, gradient is 0. So at minimum or maximum, dy dx is always 0. So let's set this thing to 0. So 6s minus 2, let's set it to 0. So this means 6s will become 2, because you take your minus 2 to this other side. You then get 2. Then to get your s, divide both sides by 2. So this will be 2 over 6, which can become 1 over 3 when you cancel out with what is common. But this is not the answer. Take note here. If JAMB tells you at what value of x or what values of x will this function be minimum, you stop here. Listen. If they say at what value of x is this minimum or maximum, you're only stopping at the value of x. You're not going further. Don't go further. But if they say find a minimum value, it's talking about y, not x. So this very x value that we have gotten, put it back into the original equation. So y is equal to 3s squared minus 2x minus 5. Oh, that's a plus 5. So this will be y equal 3 brackets. Anywhere you see x, you put 1 over 3. So this will be 1 over 3 squared minus 2 brackets 1 over 3 plus 5. So this will then become 3. 1 squared is 1. 3 squared is 9. And then this will be minus 2 over 3 plus 5. Now 3 here is 1. 3 into 9 is 3. So what will be remaining is 1 over 3 minus 2 over 3 plus 5. Now 1 over 3 minus 2 over 3, they both have the same denominator. So what is 1 minus 2? Minus 1 over 3 plus 5. But I could put an over 1 here. So what would this become? 3 times 5 is 15. Minus 1 plus 15 is 14 all over 3. So that will become the minimum value. What if the equation says the point? You should find the point. What if the equation say what's the minimum point? If any question is asking you about a point, it means you have to put the x and the y together. So as a point, the answer will become 1 over 3, 14 over 3. If they say as a point or find the minimum point, not minimum value. So I've said so many things today. So take note of that. Question 19. I've never started differentiation. That's weird. Okay. A trader receives 10x minus s squared naira profit from the sale of x bags of corn. Full stop. How many bags will give him the maximum profit? Maximum profit. Now, this very question was actually a past question. Yeah, they've asked this before. But I'm trying to use it to further explain this very thing. Because take note, it could either be minimum or maximum. But this one is going to be maximum because the s squared is negative, so it's maximum. Now, in this case, they said how many bags will give him the maximum profit. So first of all, let's say profit is equal to 10x minus s squared. If you want to even think of the maximum profit, you have to differentiate first. So what's the p dx? Differentiate p with respect to x. This will be, differentiate this 10x, what would you get to? We get 10. Differentiate s, what would you get to? We get 2x. Now remember, anything that concerns maximum or minimum, your dy dx must be 0. So this guy here must be 0. So 10 minus 2x must be 0. Take your minus 2x to the other side. This will be 10 equal to 2x. Then divide both sides by 2. This will be 5 equal to what? X. So this is what we're going to be having. Now, would I put this very value into this very place? No, I will not put the value. Why am I not putting the value? Because the equation says how many bags of whatever. But remember that the bag is represented by what? By x. It is the profit that is 10x minus s squared. So if they're asking us how many bags, it means they're asking us what's the value of what? X, to get what? Maximum profit. So this is what we have. We're going to stop here. So it's 5 bags because x represents the number of bags. But assuming the equation says what is the maximum profit, you take this very value and put it into this expression. So take note of that. Okay, that's number 19. Number 20. Oh God, this is a lot. Okay, so I want number 20 to be the last one. And let me put it this way. So a particle has a displacement of s equal 2t cubed minus t squared minus t plus 7, comma, find the A. The reason I'm doing A and B is because you could ask any of them. Don't get it wrong. JAMB will not ask 2 questions in one. So I just want to do 2 at once. So find the velocity at t equal 1 second. Then B, find the acceleration at t equal 2 seconds. Now, what if it says that find the value, find the time? Because I solved that question. I solved the question like that when I was doing the JAMB Rema for this year. What if it says find the time? Because that one, since I guess you've already watched it, if you've not, go and check the full playlist. So JAMB could also ask you, at what point, C, at what point or at what time did the particle not move? I think, yeah, not move. Or at what point was the particle stationary? So that's a whole lot of things. At what point was it stationary? So just take note, at what point was it stationary. Always notice that whenever they say at what time was it stationary or not moving, the thing need to first of all move. So you need to find the velocity. So it's already moving. But then it's going to get to a point and it becomes stationary. So let me solve this very question. Sorry. So the A part says velocity. Take note in calculus, to get velocity is ds dt. What does ds dt mean? Differentiate distance or displacement with respect to time. You are going to get velocity or speed. So they could all either say find the velocity or they could say find the speed. Take note. Now, ds dt, this is S equation. So let's differentiate this. What would we get? This will be 6t squared minus, differentiate t squared, you get 2t. Differentiate minus t, you get minus 1. So this is the expression that we have. Now this guy right here, it says what's the velocity at t equal 1 second. So anywhere you see t here, you put 1. So this will be 6 brackets 1 squared minus 2 brackets 1 minus 1. 1 squared is still 1. 1 times 6 is 6. 2 times 1 is 2 and then minus 1. So this will become what? 3. You could put the unit meter per second. This is what you're going to get. Next one is B. B says find the acceleration. Acceleration is dv dt. Differentiate velocity with respect to time. This is our velocity, right? We had 6t squared minus 2t minus 1. So with respect to time, we're going to be finding what point to get the acceleration, we need to differentiate this. So 6t squared differentiate to we get 12t, then minus 2t differentiate to get minus 2. This minus 1 is a constant, so it's gone. But it says at t equal 2 seconds. So anywhere you see t here, you put 2 seconds. But if they did not give you the 2 seconds, this will just be the answer. This will just be the answer. So this will be 12 bracket 2 minus 2. 12 times 2 is 24 minus 2. So that will be 22. And then the unit is meter per second squared. Now next is C. At what point is the particle stationary? Now ideally, this guy you see, the displacement here is an equation of distance. So logically, the body is not moving. So the body first has to move before we then say, oh, it is not moving at some particular point. So first thing is we're going to be using our velocity. Now this very equation, I will still browse about this because I was having an international student. I just remembered when I was teaching the student, there was an equation similar to this. But they equated the original expression to 0. But I remember, I can remember that they're saying that very equation, they gave the speed, they gave the velocity already. The equation they were giving was the velocity already. So if for it to be stationary, you just equate that velocity to 0. Now in this case, we're giving the distance. So first, let's find the displacement. But I'll still browse about this. But from what JAMB asked, what I solved before that JAMB asked, this is what it wants to do. If you have your displacement, this is what JAMB wants you to do. If you have your displacement, differentiate this guy first. So which we've done before. So we had our velocity. We've done that before. This will be 6t squared minus 2t minus 1. To get the point at which is stationary, means the velocity has to be 0. So this thing has to be 0. 6t squared minus 2t minus 1 must be equal to 0. There's a shortcut I always use when solving quadratic equations. First of all, this t has to times the 1. This 6 here. 6 times minus 1 is minus 6. So find two things you will times to give you minus 6. Add the same things, you get minus 2. Of course, that very thing has to become, sorry, yep. Is this thing even possible? You know, I just set the question, so I'm not really sure. Let me see. Nah, it's not possible. It's not possible. Well, you could use quadratic formula, but it is not possible for you to solve normally. So let's just leave it. But the one that we give to you, you can factorize it. Let's move on. Okay. So let's see. Let's move to the next one. I think I should even give this. Let me not give it as, I would have said, let me give it as an exercise. So in case, I'll just give it as that. And again, I've forgotten the number that I wrote here. Gosh, I keep on forgetting the number of questions that I did. I think that should be around 20 or 21 or so. Let me see. That should be 20, so this should be 21. Okay, so differentiate sine x minus s cos x. So this one is for you guys. You guys should try this one out. Let me know the answer in the comment section. You have to be very careful though. This part here, just put a bracket when you are solving, when you are differentiating this side. Just put a bracket here, because this minus might make some of your answers wrong. Okay, so let me know the answer of that in the comment section. So let's move on. I don't think there's any other thing. All right, so integration, properly, integration. 22. So these are the rules of integration. If you're integrating a constant, you basically attach x to that very constant. I don't want to give so much explanation. But then, there's always a plus c. There's always a plus c. In integration, there are two types of integrals. There's the definite integral and there's the indefinite integral. So we have definite and we have indefinite. Now, everything I've listed here, they are all definite, apart from this one. If you notice there's a here, there's b here. This one, there's no plus c in the answer because this is a definite integral. But without further ado, I'm not going to talk too much. Let's move on. So the first one, was to evaluate the integral of 4s cubed minus 1 dx. Okay, so let's do this one. So the integral of 4s cubed minus 1 dx, the answer for this, what is the rule, or what does the rule say? If you have s to the power of some number, what you have to do is to say, add 1 to that very number and divide by that whole power. So this will become 4s3 plus 1 over 3 plus 1. That's what you do. Then you say minus 1. You see this guy? The 1 here does not have s, so it's a constant. When you see something like that, you give an x. So in this case, this will just be 1x. And then plus c. JAMB would use plus c sometimes. Other times they will use plus k. Does not matter. Now this will become 4s to the power of 4 over 4 minus x plus c. Now 4 can take care of 4. So this is s to the power of 4 minus s plus c. That will be the answer. But there's another way they can write this answer. There's another way. This can actually become x bracket because s is common here. You can factorize this. S to the power of 4 over x is s cubed minus s divided by s is 1. And then plus c. So that will be the answer to the equation. It could be anything. So that's number 22. Number 23. Question number 23. Okay. All right. That's number 22. 23. Evaluate the integral 3s squared minus 2x plus 5 dx. This dx means with respect to x. So what would this integral be? It's still going to be similar. We have to say 3s2 plus 1 over 2 plus 1 minus 2s. There's an invisible 1 with this x here. So this will be 1 plus 1 over 1 plus 1. And then plus the 5 is a constant, so give them s. 5s, and then plus c. Differentiation and integration are opposite operations. They are two opposite operations. So this plus c you see here is as a result of, in differentiation, when you differentiate a constant, you get 0. So to make sure that when you take the integral, you are getting exactly the same original function, there must be a c here. This c can be solved for. You can actually solve for the c. Depends on the information given to you. So this c is a very important thing. You must always put it. Never forget the plus c. Now this will be 3s cubed over 3 minus 2s squared over 2 plus 5x plus c. So 3 we cancel 3, 2 we cancel 2. So this will be s cubed minus s squared plus 5x plus c. So that will be the answer to that very equation. Let's move on to number 24. So for number 24, it's a very tough one. Integrate s squared minus root x over x with respect to x. I used to follow some guy. He would always say with disrespect to x. Okay, so we're going to be integrating this one. Now remember that I've done something similar to this. I've done something similar to this guy. So what you basically have to do is, since you have just a single denominator, you can share it, you can distribute it. So this means that this can be the integral of s squared over x minus root x over x. You share them. This s squared will take you on. This one will take its own. Dx. Now this will become the integral. S squared over s is just x. Now remember that the square root of x on a normal day actually means the power is 1 over 2. Right? And then you put your 1 here. The power is what? 1 over 2. So this will be x, because this s squared all over, this one you already know now, no need to explain. Then minus x. This guy, let's use the law of indices here. This will be half minus 1 dx. So this will equal integral of x minus x to the power of minus half dx. Remember, I've done this thing before. Half minus 1. I've done that before. It will give you minus 1 over 2. All right, so let's now integrate. So this will be x. There's a 1 here. So this will become 1 plus 1 over 1 plus 1 minus x to the power of minus half plus 1 over minus half plus 1. And then plus c. You see this idea of always putting minus 1, always adding 1 and dividing by it. This rule here is only valid provided n is not equal to minus 1. I don't think JAMB will test you on that. But provided n is not equal to minus 1, it's valid. Okay, so this will become s squared over 2 minus x minus 1 over 2 plus 1 will give us 1 over 2 over 1 over 2. And then plus c. Now this will become half x squared, half of x squared, then minus. Now there's a lot going on here. First of all, this is 1. So this will become 1 over 1 over 2. In mathematics, when you are taking the inverse of a fraction, you are flipping that fraction. So this will be 2. Then this x here that has the power of half, you can actually write this as the square root of x. And then plus c. So this will be the answer to that very equation. That will be the answer to that very equation. Okay. Let's move on to the next. That's 25 is the next one. So what to evaluate the integral of 2x minus 3 to the power of 3 dx. All right, so this one is following this very principle here, number 3. It wants to look like the chain rule. So in integration, we call it the inverse chain rule. That's what we call it, the inverse chain rule. So the integral of 2x minus 3 to the power of 3 dx. Now see, the reason why it's easier, the reason why this is easier to, what's it called, to differentiate is because this 2x here, when you differentiate this 2x, you will just get a number. Because take note, there are times where it no work. We'll soon see. So this will become 2x minus 3. Then you have to say 3 plus 1 over 3 plus 1. Like you integrate the normal way. But then you have to say times, differentiate this very guy. Differentiate this very guy here. You will get 2. They call this inverse chain rule. The longer method of solving this is called integration by substitution. There are various methods of solving integration. You either use integration by substitution, integration by parts, or integration by partial fraction. Okay, but there's no need for that. So plus c. So this will become 2x minus 3. Then 3 plus 1 is 4. All over what? 4 times 2 plus c. So this will be 2x minus 3 to the power of 4 over 8 plus c. There's a better way of writing this. You could say this is 1 over 8 brackets 2x minus 3 to the power of 4 plus c. So this will be the answer to that question. If you differentiate this thing, you will get this thing back. So that's the beauty of integration and differentiation. Number 26. Question number 26. Okay. Take note. You only apply this. I don't think JAMB will not even set more. You only apply this when, if you differentiate this guy here, you get just a number. You get just a number. I don't think JAMB will ask more than that, sha. So evaluate the integral of, let's say we have 2 brackets 1 minus 3x to the power of 4 dx, something like this, just an illustration. So first of all, we have the integral of 2 brackets 1 minus 3x to the power of 4 dx. This 2 here is a constant multiple, so it will still multiply the final answer. Just write 2 times, let's start with integrating this. This will be 1 minus 3s to the power of 5. Because you need to say 4 plus 1 over the same 4 plus 1, so that's 5. Then times, you must divide by, differentiate the 1 minus 3s. What would you get? You get minus 3. Because when you differentiate 1 is 0. Then when you differentiate minus 3s, you will get minus 3. Take note, I know you are surprised. We are doing integration, but there's differentiation inside. Yes, so they are connected. And then plus c. So this will become 2 times 1 minus 3s to the power of 5 over 5 times minus 3 is minus 15. And then plus c. So this is what we have. All right. Now there's a better way of writing this. You could say this is minus 2/15 bracket 1 minus 3s to the power of 5 plus c. So that's just a better way of writing it. The next one, number 27. Number 27. Integrate 1 plus x divided by s cubed dx. Remember that dx means with respect to x. So this is not hard also. So we have the integral of 1 plus x over s cubed dx. Now this is a single guy at the denominator, so we just share it. This will become the integral of 1 over s cubed plus x over s cubed dx. You could put a bracket if you wish. Now 1 over s cubed is going to become s to the power of minus 3. Remember that in indices, you could clear out, you could remove this very 1 over. Okay, and then plus s over s squared. This would actually give us 1 over x squared. But that guy would then become s to the power of minus 2. Okay, look. X over s cubed. There's a 1 here, right? So this will be x to the power of 1 minus 3. So this is s to the power of minus 2. So that's why I wrote that. And then dx. Now what do we do next? We're now going to use this rule. We're going to say plus 1. So this will be s to the minus 3 plus 1 over minus 3 plus 1. Then plus x minus 2 plus 1 over minus 2 plus 1. And then plus c. So this will become s to the power of minus 3 plus 1 is minus 2. And then plus x minus 1 plus 2 is minus 1 plus c. Now this minus can come to the front. This is even 1. There's an invisible one here. So this will become minus 1 over 2 x to the minus 2. Then this is a 1 here. 1 over minus 1 is minus 1. So this will just be minus x to the minus 1 plus c. There's a better way of writing this answer. We could say this is minus 1 over 2s squared. Remember that to clear out this minus, we say 1 over. So there's already a 1 here. So this s to the power of minus 2 will now join this very 2 under. And then minus this guy here will become 1 over x plus c. So that will become the answer to that very equation. Very nice one. A very nice one. Number 28. Evaluate the integral of sine x minus 7 dx. Alright, so if you are to integrate sine x, take away 7 dx. What we'll be having is, if you integrate sine, you will get minus cos. So this will become minus cos x. Then this is minus 7. If you integrate minus 7, 7 is a constant, you don't get s, so give an s. Minus 7x, and then plus c. This will be the answer. That's a simple one. This will be the answer. Number 29. Integrate cos 4x dx. Alright. I said integrate cos 4. Integrate cos 4s dx. Now, to integrate this cos 4s dx, what we're going to be doing is, this guy that you see here, let's come back. 4x, you know, there's no 4x here, right? But here's what you will do. Each time you're asked to integrate a trig function, and this is an angle, first of all, differentiate 4. So what will you get? You will get 4. So you have to first write 1 over 4. You will not just write the 4, you say 1 over. Because if you notice here, integration will be like opposite of differentiation. So here we say 1 over. Then times integrate cos. When you integrate cos, you will get sine. So this will be times sine. Then you put the angle back, 4x. And then plus c. So this will become 1 over 4 sine 4x plus c. That will be the answer. That will be the answer. Number 30. The integral of sec squared theta d theta. Now this is a simple one. That's saying you should integrate sec squared theta. Come here. If you integrate sec squared x, you will get tan x plus c. So since everything is in terms of theta and not x, this will become tan theta plus c. That will become the answer to that very equation. So that was a simple one. That will be the answer to that very equation. All right. Next one. Number 31. Given that, let me see. Okay, I have no choice. Given that 0 is less than or equal to x less than or equal to 1, find the area under the curve y equal 3s squared minus x plus 5. Now let me pick a very small number, plus 2. Okay, so this is what we have. This is one of the applications of integration. So what we're going to do here is, it's very simple. To find area under the curve, area is the integral from a to b of y dx. So this will become the integral from our y is 3s squared minus s plus 2. The limit was 0 to 1. Take note here, this guy you see here, this is lower limit, so it's always smaller than this one. This lower limit, this upper limit. So the number here should be smaller than this one, than dx. So let's integrate. So this will become 3x, there's a power of 2 here, so this will become 2 plus 1 is 3 over 3. Then minus, this is x, so this is x 2 over 2. There's an invisible 1. So you say 1 plus 1 over 1 plus 1. And then plus this very 2 is a constant, so this is 2x. And then plus c from 0 to 1. Take note, this plus c, it can disappear, you can just throw it out. Now 3 can cancel out 3. So this will be s cubed minus half s squared plus 2s plus c from 0 to 1. Now what do we do? After integrating it, Anywhere you see s, put your upper limit. So anywhere you see s here, put 1. So this will be 1 cubed minus half times 1 squared plus 2 times 1 plus c. Then the next one, anywhere you see s, you put 0. But everything will just be 0 now, so why stress ourselves? Because 0 cubed is still 0. Minus half times 0 squared plus 2 times 0 plus c. Okay, 1 cubed is 1 minus half times 1 is half, then plus 2 plus c. Minus everything here will just be 0 plus c. Now 1 plus 2 is what? 3. So this will be 3 minus half plus c. Now minus times c is minus c. So you see that this will cancel out. Now what's 3 minus half? This will be 5 over 2. So the area will become 5 over 2 square units. You could take LCM or you can take LCM and just do the same thing. You can take the LCM and your answer will still be this. Okay, 5 over 2. You could put square units since we're talking about area. All right, the next one. For the next one, there might be no... Okay, that's 31. 32. If dy dx is equal s plus cos x, you have to find y. They're saying that they've differentiated something. They're not saying, what was that they differentiated? That's what they mean. So if dy dx has already been given to you as this, to get your y back, differentiate both sides. To get your y, differentiate both sides with respect to x. So this will give us our y, because there are two opposite operations, integration, differentiation. This will just give us our y. Integrate s, you know, so now 1 day here. So this will be s to the power of 1 plus 1 is 2 over 2. Then plus, this is cos s. Integrate cos, what would you get? You will get sine. So this is sine x. And then plus c. This is the answer. The only better way to write this is to say that this is 1 over 2s squared plus sine x plus c. So that's just it. Okay, let's move on to the next one, question 32. We're almost done with this. I think we have just about 2 more questions remaining. That's just it, 2 more questions remaining. Question 33 says, find the area of the figure bounded by the pair of curves y equal s squared minus x plus 3 and y equal to 3. It's just one that is a curve. Don't mind them. This is also a line. This is a line. This is a curve. So to solve this very equation, remember to find area, you need the limit because the area is a definite number. It's not indefinite. There should be no plus c when you're looking for area. So the first thing you do is to equate these two things together. Equate them. Equate the curve and equate this guy. So s squared minus x plus 3 will be equal to 3. Well, these two guys are the same. So even if you take your plus 3 to this side, you will get 3 minus 3. So that's 0. So s squared minus s is equal to 0. That's the meaning. Now, if you notice, what's common here is x. So s squared over s is x, minus s over s is 1, equal to 0. Now, if you are multiplying two things and any of them is 0, it means that, if you're multiplying two things and the answer is 0, it means any of them could have been 0. So s is equal to 0 or x minus 1 is equal to 0. So this s equal to 0 already simplified. Or take your minus 1 to this other side. This will be 1. So that means our limit will become from 0 to 1. Take note, a question can be asked like this. Not just calculus. A question can be asked like they will tell you the graph of y equal s squared minus s plus 3 and y equal to 3 was drawn on the same axis. Then the question is, what graph is the person trying to solve? Take note, the graph become the graph of s squared minus x. So this is like our resultant equation of these two. When these two things combine, this is our resultant equation. So to get our area, this will become the integral from 0 to 1 of s squared minus x dx. That's what our area will be. But take note, area is always positive. Area is always positive. Ideally, I would have found out, it's a long process, a little bit long though, or it will make my solving a little bit long. I would have found out between these two, which of them will be above and which of them will be below. But I don't have the time for that. So let's just find the derivative, the integral of this. So this is s squared. So this will become s3 over 3 minus what? Minus s squared over 2. Because remember, there's an invisible one here. So to integrate, we're going to say 1 plus 1, 2 over 2. I don't want to put the plus c because I know it will still go away. So no need. So now what do? Anywhere we see s the first time, we put 1. So this will be 1 over 3 minus 1 over 2. Then minus second time, we put 0. Everything will just be 0. Everything will just be 0. So what's 1 over 3 minus 1 over 2? When you take your LCM is 6. So this will become 2 minus 3. So this is minus 1 over 6. But remember, we must take the absolute value because area is always positive. So the area here is actually 1 over 6, not negative. So just take note of that. It's not negative. It's going to be that very value. The next one, question 34. So question 34, we have to evaluate the integral from 1 to 3 of s squared minus 1 dx. Oh, that's nice. Okay. So the integral from 1 to 3 of s squared minus 1 dx. First of all, let's integrate s squared. This will be equal to s cubed over 3. Then minus, this one is a constant, so this will just be x, or you could say 1x. If you have a constant, just give an x. Then this is from 1 to 3. So now what do? Anywhere we see s the first time, we put 3. So this will become 3 cubed over 3 minus 3. So this for the first one, minus. The second one, anywhere we see x here, we're going to put 1. Anywhere you see s, we put 1. So this will be 1 cubed over 3 minus 1. 3 cubed over 3. 3 cubed first of all is 27. 1 cubed is 1. 27 over 3 is 9. 9 minus 3 will give us 6. Then minus 1 over 3. Minus times minus is plus. So this will become 6 plus 1, so that's 7 minus 1 over 3. So what's 7 minus 1 over 3? 7 times 1 is 21. 21 minus 1 is 20. So this is 20 over 3. But remember, just do your LCM in peace so you get what's going on here. Just get the LCM in peace here. All right. Next one. Number 35. We're close to the end. 35 says the gradient of a curve is 2x plus 7, and the curve passes through the point 2, 0. Find the equation of the curve. All right. So for this guy, the first thing you need to know is gradient means dy ds. So that's saying that dy ds is equal to this very value, 2s plus 7. Now we're saying, what is the original equation of the curve? They differentiated an equation to get this. So to get that original equation back, we do the opposite of differentiation, which is integration. So integrate both sides. When you integrate this, you get your y because they are opposites. Then integrate 2s. You know this 2s can be raised to the power of 1, or it is raised to the power of 1. So this will be 2x. 1 plus 1 is 2 over 2. This is 7. So this will be 7x when you integrate, and then plus c. Now 2 we cancel out 2. So y is equal s squared plus 7s plus c. But of course, we were told that is at this point. So this c value, let's find the c value. We were told that it passes through the point 2, 0. So what do? Remember that s is always the first, y is the second. So that's saying that y is 0. So we're using this guy. So y is 0 when s is 2. So this will be 2 squared plus 7 bracket 2 plus c. So this will become 0 equal 4 plus 14 plus c. That's 0 equal 18 plus c. Take your 18 to this side. So that's minus 18 plus c. And then we can now put this back into the original curve or equation of the curve that we had. Y is equal s squared plus 7x plus c. So this will become y equal s squared plus 7x. This minus 18 will not be here. So this will now become the original equation of the curve. This is what it will not be. The original equation of the curve. That will be the answer. All right. So, number 36. Number 36 says we should evaluate the integral from 0 to pi over 2 of sine 2x dx. All right, so we're almost done. All right, so we have the integral from 0 to pi over 2 of sine 2x dx. First of all, remember if you have to integrate a trig function, start with the angle. This is 2x. Differentiate 2x, you are going to get 2. So this will become 1 over 2. Then times integrate sine. When you integrate sine, you get minus cos. So this will be minus cosine. You put the angle back, 2x. That's what you're going to do. And then you put your limit 0 to pi over 2. So this will become minus half cos 2x. And then we're going to be having our 0 and pi over 2. Now take note, take note. Pi, each time you see pi, pi in this case is going to become 180 degrees. Take note, pi is equal 180 degrees. They call it pi radian. So pi radian is what? 180 degrees. So anywhere we see s, we're going to put this pi. So this will be minus 1 over 2. And then cosine 2 brackets pi over 2. And then minus cos. Anywhere we see s, we'll now put 0. So this will be 2 brackets 0. Okay, so this is minus 1 over 2. Now 2 we cancel out 2 here. So this will be cos pi. And then minus cos. This has to give us 0. To give us 0. So be aware. Now this will become minus 1 over 2. Now in this case, this will be cos pi is 180 degrees. Take note, the one you might be given in the exam might become maybe pi over 3. But just keep it in mind that pi is 180. So you know that this is 180 over 3. So that will become what? 60. Just keep it at the back of your mind. And then minus cos 0. Let me just leave that as cos 0 for now. So this is minus 1 over 2. Cos 180 is minus 1. And then minus cos 0 is 1. So this will become minus 1 over 2 times minus 1 is minus 2. So this minus will cancel out this minus. 2 will take care of 2. So the final answer is just 1. That's what you're going to be getting. So this is all. You could maybe try out these other ones. Add it to, oh, I've even cleaned it up. Add it to this. Also, this will be 37. Let's say the integral from pi over 4 to pi over 2 of cos x dx, something like this. Then 38 would be if y is equal to sine 3x, find dy dx at x equal to pi over 6. These are nice questions. All right, so with these few points of mine, this will be the end of this video. Remember to hit the subscribe button, like this video, and share it across to everybody. Share it across to your classmates, and I want you to be successful. You're going to pass your exam and you're going to be in the university very soon. Remember to keep on watching other videos that would help you out in mathematics. Bye.